Today we will solve the problem by integration method or by first principle for the moment of inertia about x and y axis for the area under the curve. So this is the problem. Find the moment of inertia about x-axis and y-axis for the shaded area under the curve y is equal to kx square. So this is the x-axis and y-axis, and this is the curve y is equal to kx square, and this is the shaded area. So we have to find the moment of inertia about this x-axis and about this y-axis for this shaded area. So now for this we will take a strip in this area as earlier. This is at a distance x, and the thickness of this strip is dx, and height is y. Height is y. So now area of the strip, which is dA, is equal to y into dx. So this is the area of the strip. Now we find the value about this y-axis for the moment of inertia. So Iy is the moment of inertia about this y-axis for this strip. So for this strip, it is equal to y square into x square into dA. This x square into dA for this strip about y-axis. Now for this whole area we will integrate it and put the value of dA is y dx. So here is dx. So for this we will put the limit 0 to a, because it is from x is from 0 to a. Now y is equal to kx square and k is equal to y upon x square. Now putting the value of x and y. So if x is equal to a, then y is equal to b. So b upon a square. K is equal to b upon a square. So now put y is equal to, in place of k, b upon a square and into x square, b upon a square into x square. So this value of y we put here in place of y, because we require x in place of y. So now 0 to a, this is x square, and in place of y, b upon a square into x square dx, or b upon a square is constant, so it come outside, and 0 to a x to the power 4 into dx. So for this b upon a square, and it is x to the power 5 upon 5, and limit is 0 to a. So this is equal to b upon a square into, put the limit a to the power 5 upon 5. So this is equal to, by a square it will come out at a cube, so b a cube by 5. So this Iy is equal to b a cube by 5. So this is Iy. Now we find Ix. Ix means about this axis. About this axis. Ix. So we will find the moment of inertia for this strip about this x-axis. So this is a rectangle, and for this rectangle, this is the base. So about this x-axis, the rectangle is bh cube by 3. Moment of inertia earlier we have find is bh cube by 3. Like this, this is a x-axis, and this is the strip, and this height is y, and this thickness is dx. So for this is b and this is h. So for this, Ix is dx into y cube by 3 for this strip about this xx line, this baseline. So similarly, for this strip about this baseline, we put dx into y cube divided by 3, and here also dx. So for this dx, we will put the limits from 0 to a. 0 to a. So here in place of y, we place the value of y, that is b upon a square into x square. So here in place of y, we put the value limit 0 to a and b upon a square into x square whole cube into dx by 3. In place of y, we put the value b upon a square into x square. So now 0 to a, and this is b cube upon a to the power 6, because a square to the power cube. So b cube upon this 3 a to the power 6, and now x to the power 6 into dx. So this constant b cube upon 3 a to the power 6 come out, and integration of this x to the power 7 upon 7, and limit is 0 to a. So on putting the limit, b cube upon 3 a to the power 6 multiplied by a to the power 7 upon 7. So this will be equal to a to the power 6, and this power cancel. So remaining is only a. So this is ab cube upon 7 into 3 is 21. So this is for Ix. So this is the moment of inertia of this shaded area about x-axis. So ab cube by 21, and for this about y-axis is ba cube by 5. Okay, so this is Ix and Iy. Okay, thank you. Now this is the question. We have to find out the moment of inertia of this shaded area enclosed between this line y is equal to mx and this y is equal to kx square about this x-axis and this y-axis. So here, as earlier, we will find the moment of inertia of this whole triangle. This triangle from here to here. For this triangle, we will find the moment of inertia, and then from this triangle we deduct the moment of inertia this area of this area under this y is equal to kx square curve calculated earlier. So we will find, so we can find this moment of inertia of the shaded area. So now for this triangle we will take the strip as earlier of height y and at a distance x of this thickness dx of this thickness dx. So now the area of the strip is area of strip dA is equal to y dx. So now Iy for this triangle, so this will be equal to x square into dA, or limit is 0 to a. On putting the value of dA is 0 to a, x square into y into dx, y into dx here for the triangle. Now from this y is equal to mx and m is equal to y upon x, or this m is equal to b upon a. So y is equal to b upon a into x by this equation number 1. So y is equal to b upon a into x. So on putting this here, so 0 to a, and this x square in place of y, b upon a into x dx. Now this is constant is out, b upon a, and this is 0 to a x cube into dx, or on integrating and on putting the limits, b upon a x to the power 4 upon 4, or limits are 0 to a. So this will give you b upon a into a to the power 4 upon 4, and this will be equal to a cube b by 4. So this is for this is Iy for the triangle, for triangle. Now earlier we have calculated for area under y is equal to kx square from calculated earlier. Iy, suppose this is area under this curve is 2 and triangle is 1. So Iy1 and this is Iy2. So we have calculated earlier Iy2 is a cube b upon 5 calculated earlier. So now for this shaded area, Iy is equal to Iy1 minus Iy2. So this will be equal to a cube b upon 4 minus a cube b upon 5, or this is equal to iy is equal to a cube b by 20. So for this, a cube b by 20. Now similarly, for this triangle, we find the ix1. So this ix1 is equal to, as earlier, for this strip, moment of inertia about this line, x-axis, dx into y cube by 3, dx into y cube by 3. So on putting this limits dx into y cube by 3 and on integrating between the limits 0 to a. Now in place of y, we will put the value b upon a into x. So on putting this 0 to a and on putting b cube upon 3 a cube into x cube into dx. Okay, so like this, b cube upon 3 a cube is constant and integration of this is x to the power 4 upon 4 and limit is 0 to a. So on solving it, we will find b cube upon 3 a cube into a to the power 4 upon 4. So by this, ix1 is equal to 3 into 4 is equal to 12, and this b cube a cube cancel this power 4 and only remaining a. So ab cube upon 12. So this ix1. Now for area under the curve y is equal to kx square calculated earlier as iy2 is equal to ix2, sorry, ix2 is equal to ab cube by 21 in last question, ab cube by 21. So ix is equal to ix1 minus ix2, or it is equal to ab cube upon 12 minus ab cube upon 21. So on solving this, we can find out the value of ix is equal to ab cube upon 28. So this is the value for ix, ab cube upon 28 for this shaded area about this x-axis. So in this question, we have used the values ix2 is equal to abq upon 21 calculated earlier, and here also iy2 aqp upon 5 calculated in earlier question. But if the question is asked, you have to solve both the values. So now here we have used the earlier calculated value. So by this ix is equal to abq upon 28, and here iy is equal to aqp upon 20. Okay, this is the answer. Thank you. Now in this problem we have to find out the moment of inertia of this shaded area about this x-axis and this y-axis. So for this we will take a strip of height y and at a distance x of thickness dx of the height y and thickness dx. Now the area of the strip is dA is equal to y dx. dA is equal to y dx. So now moment of inertia x square dA, and integrate it for the total moment of inertia between the limits. Now putting the value of dA is x square into y dx. So here dx, so limits of x from 0 to a. This is a from 0 to a. Now in place of y, put the value in terms of x. So curve is given as y is equal to kx to the power 1 by 2, or k is equal to y upon x to the power 1 by 2 is equal to b upon a to the power 1 by 2. Y is equal to b and x is equal to a. So b upon a to the power 1 by 2. Or by putting it in equation number 1, this y is equal to b upon a to the power 1 by 2 into x to the power 1 by 2. Y is equal to b upon a to the power 1 by 2 into x to the power 1 by 2. Now put it in place of y here. So this will be equal to integration 0 to a and x square in place of y, b upon a to the power 1 by 2 into x to the power 1 by 2 into dx. Or this will be equal to b upon a to the power 1 by 2 and this integration 0 to a, and this is x square plus multiplied by x की power 1 by 2. So this will be equal to x to the power 5 by 2 into dx. Or this is equal to b upon a to the power 1 by 2 into integration x to the power 7 by 2 upon 7 by 2 on limits 0 to a. So on putting limits, b upon a to the power 1 by 2, and this is equal to a to the power 7 by 2 upon 7 by 2, and this will be equal to 7 by 2 is 2 by 7, so 2 by 7 and into b at 7 by 2 power 7 by 2 minus 1 by 2. So it will be equal to 6 by 2 is equal to a cube. So from this we can find out the value Iy is equal to a cube b 2 by 7 for this. Iy is equal to 2a cube b divided by 7. Now for Ixx, for this Ixx, as earlier, we will find out the moment of inertia about x-axis for the strip. So for this vertical strip about this x-axis, the moment of inertia is dx into y cube divided by 3 for the base of a rectangle. So at the base of a rectangle, dh cube by 3. So this is equal to dx into y cube by 3. So this is equal to Ix is equal to y cube into dx by 3. So in place of y, put the value this integration sign, limits are 0 to a, and in place of y, put this value y is equal to b upon a to the power half into x to the power half. So b upon a to the power half into x to the power half cube into dx by 3. So this will be equal to b cube upon 3 a to the power 3 by 2 comes out, and the integration of x to the power 3 by 2 into dx, and limit is 0 to a. So this will be equal to b cube upon 3 a to the power 3 by 2 into integration is x to the power 5 by 2 upon 5 by 2, and limit is 0 to a. So on putting this limit, this will be equal to b cube upon 3 a to the power 3 by 2 into a to the power 5 by 2 divided by 5 by 2. So by this Ix is equal to 2 goes on upper side. So 2 upon 5 into this 3. So 2 upon 15 into this b cube into a to the power 5 by 2 minus power 3 by 2. So this is 2 by 2 is equal to 1. So this is a. So this will be the moment of inertia of this figure about Ixx. So this Ix is equal to 2 upon 15 into b cube a for this shaded area. And Iy is this 2a cube upon 2a cube b upon 7. So this is Iy and this is Ix. So both are calculated by taking a strip at a distance x of thickness dx and vertical height is y. So taking moment of inertia of this strip about x-axis and y-axis, then integrating it between the limits 0 to a. Iy is equal to 2a cube b upon 7 and ix is equal to 2 by 15 b cube into a. Okay, thank you very much.